Now in continuation, let's do some more practice on quadrilaterals, especially on midpoint theorem, right? As it is very, very important. So look at this question number 11. In this question, E and F respectively are the midpoints of the non-parallel sides AD and BC of a trapezium ABCD, right? As you can see in this figure here, right? ABCD is a trapezium, okay? And E and F are the midpoints of the non-parallel sides AD and BC, right? Is that clear? So here parallel sides are which one? AB and DC. These are parallel sides. And what are non-parallel sides? AD, this one, and BC, right? And the midpoints of these two non-parallel sides are given here, that is E and F. Okay, so this much is given here. Now, what you have to prove? You have to prove that EF is parallel to AB, right? So you have to prove that this also parallel to AB, right? Okay, EF is parallel to AB, and EF is equal to half of, this is equal to half of AB plus CD. Okay, EF is equal to half of AB plus CD. Okay, so this is the question. Okay, so let's see how to solve this. Now, what we will do, we will join here DF. We will do some construction here, right? We will join DF. Let's join D and F. And we will produce it so that it will meet, right? And if we produce AB also, then they are meeting at a point here. Okay, is that clear, right? So suppose this point is G, right? Okay, so what we have done here, write down, join DF and produce it to meet AB, produced in G, right? So we have produced both of them, DF and AB, and they are meeting at a point here, that is G. Getting that? Now, in triangle DCF, look at the triangle. In triangle DCF, this one, DCF, and GFB, okay, this is GFB, smaller one, right? DCF and GFB, right? These are the two triangles. So if you can see these two triangles, angle DFC, this one, is equal to angle GFB, right? These two angles will be equal. Why? They are vertically opposite angles, right? So write down angle DFC is equal to angle GFB. Why? These are vertically opposite angles, right? So since these are vertically opposite angles, they are equal, right? Then CF is equal to BF. Just look at it. CF and BF will be equal. Why? This is given in the question because F is the midpoint of CB, right? Okay. So write down, since F is the midpoint of BC, right? So this angle is equal to this angle, right? And CF is equal to BF, right? Because they are equal since F is the midpoint of BC. And along with this, angle DCF is equal to angle GBF. Look at the questions. Angle DCF is this, and angle GBF is this one. They are equal. Why? Why they are equal? Because they are alternate interior angles. Is it clear? Because we know that AB and CD are the parallel lines, are the parallel sides of the trapezium. And since we have produced AB only to G, right? Okay. So BG will also be parallel to CD. Is that clear? Right? And since they are parallel, okay, so BC will behaving as the transversal here. Getting it? BC is behaving as a transversal among between these two parallel lines CD and BG, right? And there's a reason these two angles are the alternate interior angles, and they will be equal. Are you getting that? Okay. So now down DCF and GBF angles are equal. They are alternate interior angles. Okay. Because you can write down DC is parallel to BG and BC is the transversal. BC is the transversal, right? So therefore, angle DCF and GBF are alternate interior angles which are equal. So for these two triangles, can we say that they are congruent, right? So we can say that triangle DCF is congruent to triangle GBF, right? By which property? By ASA congruence criteria. Okay, by ASA congruence criteria, right? Okay, angle, side angle, right? Okay, so these both triangles are congruent by ASA congruence criteria, right? Now, since we have proved that these two triangles are congruent, by CPCT, we can say that DF is equal to GF. Look at the figure. DF is equal to, that means this side will be equal to this side, GF. Getting it? Okay. By CPCT, they will be equal, right? So write down by CPCT. Okay. They are equal. Now, DF and GF are equal. And along with this, CD will be equal to BG. CD will be equal to BG, right? This and this side will also, however, they were parallel. Now we have proved that they are equal as well. So CD and BG will be equal, right? Again by CPCT only. Okay. So now, okay. So now, if we see triangle DAG, triangle DAG, look at the triangle DAG. DAG, this bigger one. Okay. This is DAG. Okay. Now in this triangle, what do we have? Since we already know that E and F are the midpoints, okay, of AD and DG. Getting that? Okay. And EF is parallel to AG.
Yes, ma'am. Now I am back.
Okay. EF is parallel to AG. Yes or no? EF is parallel to AG because EF is parallel to AB, right? Why? Because F is the midpoint and E is the midpoint. So by midpoint theorem, EF will be parallel to AB as well as BG, right? And it will be equal to half of AB. Getting it? EF will be equal to half of AB, right? Half of AG. Getting that? So that means what? By midpoint theorem, we can say that EF is parallel to AG as well as half of AG. Getting it? Okay. So write down. So in triangle DAG, E and F are the midpoints of sides AD and DG respectively, right? So therefore we can say EF is parallel to AG and EF is equal to half of AG, right? By which theorem? By midpoint theorem. Okay, by midpoint theorem we can write this. Okay, so that EF will be parallel to AG as well as it will be half of it, right? Now, EF is parallel to AB, right? Yes or no? EF is parallel to AB also, right? Getting that? Okay. And EF is equal to AB plus BG, right? Okay, EF is parallel to AB and EF is parallel to half of AB plus BG, right? Because AG is equal to AB plus BG. Getting that? So we can write it. So write it down. EF is parallel to AB and EF is half of AB plus BG. Getting this? Because AB plus BG is AG only, right? Okay. And we already know that from this equation, CD is equal to BG, right? Okay. From these equation, suppose this equation number 1. So from equation number 1, we can write that EF is parallel to AB. Now, we can write EF is equal to half of AB plus CD, right? So instead of BG, we are writing CD, right? Why? Because BG and CD are equal, right? This we have already proved we have proved the congruency of the triangle, right? So by CPCT, we have proved that BG and CD are equal, right? So in this way, we can write down that EF is also equal to half of AB plus CD. Is that clear? So you can write down since BG is equal to CD. So in this way, we have proved that EF is parallel to AB, okay? EF is parallel to AB and equal to half of AB plus CD. Okay, so we have proved this one. So I hope you're getting this. Please note it down. Now look at this question number 12. Here, ABC is a triangle, as you can see in the figure. ABC is a triangle, and D is a point on AB, right? So D is the point on AB, such that AD is equals to 1 by 4 AB, right? Means this part is 1/4 of the whole length AB, right? And E is the midpoint on AC such that this part AE is 1/4 of this whole length AC, right? Now we have to prove that DE is equals to 1 by 4 of BC. Okay, we have to prove that DE is equals to 1 by 4 of BC, right? So this is given in the question and we have to prove that DE is equals to 1 by 4 BC, right? So now how to do this? Now suppose P and Q be the midpoints, right? So let's assume that there are 2 points on P and on AB and AC, which are the midpoints, right? So suppose this and this, okay? P and Q, getting it? P and Q are the midpoints. So write down, let P and Q are the midpoints of AB and AC respectively. Okay, so we have taken the midpoints of AB as P and midpoint of AC as Q. Okay, now let's join this P and Q. Okay, now this PQ will be parallel to BC. Yes or no? Will be parallel to BC, right? And PQ will be equal to half of BC. By which theorem? By midpoint theorem. Okay, by midpoint theorem, we can say that this PQ is parallel to BC and half of it, right? Okay, this is the midpoint theorem, right? Line joining the midpoints of the two sides of a triangle is parallel to the third side and equal to half of it, right? So this is our midpoint theorem. So by midpoint theorem, we have written it, right? Okay, so PQ is equals to half of BC. This is our suppose equation number 1, right? Now, look at the triangle APQ. In the triangle APQ. Okay, in triangle APQ, this is smaller one, the upper one, in triangle APQ. Okay, so in this triangle, D and E are the midpoints. Yes or no? These are the midpoints of AP and AQ, respectively, right? Because P is the midpoint of AB and D will be the midpoint of AP because D is equal to 1/4 of AB, right? So it would be the midpoint of AP, right? Okay. Similarly, Q is the midpoint of AC and E, which is already given in the question, that AE is 1/4 of AC. That means A will be the midpoint of AQ, right? Okay. So by this, we have written it, right? That D and E are the midpoints of AP and AQ respectively. Now, since they are midpoints, right? And the line joining the midpoints of a triangle, right? Of the two sides of a triangle will be parallel to the third side and equal to half of it, right? So again, we can write it as that DE will be parallel to PQ, right? So what is the third side here? Your third side is PQ, right? So DE will be parallel to PQ and half of it. Getting it? Okay. So DE will be parallel to PQ and DE is equal to half of PQ, right? And this is suppose your equation number 2, right? And why we have written this? Again, by midpoint theorem. Always write down which theorem you are using, right? Okay. You need to write the name of the theorem. So by midpoint theorem, we have written it. Now from equation number 1 and 2, right? Okay. So what is your equation number 1? PQ is half of BC and DE is half of PQ, right? So you can put the value of PQ from here, from equation number 1, right? So DE is equal to half of PQ. And when you write the value of PQ from equation number 1, it is equal to half of BC, right? So we can easily prove that DE is equals to 1/4 of BC. Okay, and same thing we have to prove in this question, right? So we have to prove here that DE is equals to 1/4 of BC. Okay, so we have proved it here that D is equal to 1/4 of BC, and hence it is proved. So I hope you are getting it. Please note it down. Now look at this question, question number 13. ABCD is a parallelogram. Okay, as you can see here in this figure. Okay, ABCD is the parallelogram. E and F are the midpoints of AB and CD respectively, right? So E is the midpoint of AB and F is the midpoint of CD, right? Now, GH is a line. There is some line GH, as you can see here. This is the line GH intersecting AD at point G, okay? EF at point P and BC at point H. And now you have to prove that GP, this is equal to PH. Okay, you have to prove that GP and PH are equal. Okay, so this is given here. Okay, so ABCD is a parallelogram. E and F are the midpoints of AB and CD, right? And there is a line GH, which is intersecting AD at G, EF at P, and BC at H. Okay, and now we have to prove that GP and PH are equal. Okay, now as it is already given here that E and F are the midpoints. Okay, this is already given, midpoints of AB and CD respectively, right? Okay, so this is already given that E and F are the midpoints of AB and CD, right? So can we write as AE is equals to BE, right? AB and BE are equal. Getting that? Or this can be written as half of AB, right? Similarly, A, similarly CF is equal to DF, right? This part and this part are equal, right? Because F is the midpoint of CD, and this is equal to, can also be written as half of CD, right? Okay. But AB and CD are equal. Yes or no? But AB is equal to CD. Why? Why AB and CD are equal? Because this is a parallelogram. Yes or no? Since ABCD is a parallelogram. So for a parallelogram, opposite sides are parallel and equal in length, right? So AB and CD are equal. That means what we can say from this? We can write that half of AB means this and this are equal, right? Half of AB will be equal to half of CD. Getting it? Half of AB and half of CD will be equal, right? Because AB and CD are equal, so therefore their half of these lines will also be equal. And half of AB is BE. From here, half of AB is BE. Similarly, half of CD is CF, right? Okay, so write down half of AB is BF and half of CD is CF. Getting it? Okay, and sorry, this is not BE, this is BE, not BF. Okay, please correct it. Okay, half of AB is equal to BE, so this is BE, right? So we have proved that BE is equal to CF, right? And also BE is parallel to CF. Yes or no? BE is parallel to CF. Why? Because AB is parallel to CD, so their part will also be parallel to each other, right? So BE will be parallel to CF. Getting that? Okay. So can we say that since BE is equal to CF and BE is parallel to CF, can we say that BEFC is a parallelogram? Right? So can we say that BEFC is a parallelogram? That means this is a parallelogram. This is smaller part. Getting it? Okay. So BECF is a parallelogram. So from here, since we have proved that this is a parallelogram, so can we say that BC and EF, these two sides, opposite sides, are parallel and these are parallel, right? Okay. BC and EF are parallel. And BE is equal to PH, right? BE is equal to PH. Getting that? Okay. So write down. From here we can say that BC is parallel to EF. Okay. And BE is equal to PH, right? Now, BC is parallel to EF. Okay. That means AD is parallel to EF. Now look at the figure. Since BC is parallel to EF, BC is parallel to EF. That means AD, this one will also be parallel to EF. Getting it? Okay. Because that part is also a parallelogram. Is that clear? So can we say that the bigger one is also a parallelogram? So can we say that AEFD is a parallelogram? Okay. That means AEFD is also a parallelogram. This one is also a parallelogram. Okay. AEFD is a parallelogram. So from here, we can say that AE is equal to GP, right? So suppose this is your equation number 1 and this is your equation number 2, right? So here, from here, we have proved that A is equal to GP, right? But E is the midpoint of AB. E is the midpoint of AB, right? And AE is equal to BE. right? Okay, A is equal to BE. So write down, but E is the midpoint. E is the midpoint, please wait, of AB, right? Therefore, AE is equals to BE, right? Are you getting that? Okay, A is the midpoint, so AE and BE will be equal, right? Okay, so now AE and BE are equal, means this and this are equal. So can we say that GP and PH will also be equal from first and second? Getting that? Okay, so write down. Suppose this is equation number 3, right? Now from 1, 2, and 3, 1, 2, and 3, we can say that GP is equal to PH, right? So we have proved that GP is equals to PH using these 3 equations. And hence we have proved this. I hope you're getting this. So listen here. So in this question, what we have done, we have equate, because since AEFD is a parallelogram, we have written that AE and GP are equal, right? And BEFC is a parallelogram, and that's why we have written BE and PH are equal, right? Okay.
Yes, ma'am.
So if BEFC is a parallelogram, right? Okay, PH will be equal to BE. Why? Why they will be equal? Because EF and BC are parallel lines, and the
Yes,
distance
ma'am. EF and BC
between the parallel lines will always remain same,
remain same.
right? Okay, so that's the reason we have written BE and PH are equal. Similarly, when we are considering AEFD, which is a parallelogram, right? Here we have written that GP and AE are equal.
Yes, ma'am.
Right? Okay, why? Again, the similar thing, because DF and AE is a parallelogram, right? The opposite sides are parallel and equal, right? And if we draw a line parallel to it, right, that will also be equal to the AE or DF. Is that clear?
Yes,
Because
ma'am.
the distance between the two parallel lines will always remain same.
Yes,
That's the
ma'am.
reason we have written AE is equal to GP, okay, and BE is equals to PH. And
PH.
since we know that AE and BE are equal, therefore GP and PH will also be equal to each other. Okay, so same thing we have done here in this question. So I hope now you're getting it.
Yes, ma'am.